We need to obtain the value of derivative of y with respect to x at theta equals to pi over 4 radians whenever x and y are given in its parametric form. So in our case, x and y are dependent on the parameter theta. So let's begin. So here we'll have our function x given as a times cosine cube theta, but we can also express that as cosine theta whole cube. Similarly, we have y, which is given by a times sine cube theta. We can represent it as a times sine theta whole cube. Now what we'll do, we'll take the derivative of x with respect to theta. So this will be equals to a being a constant. So we have a multiplied to derivative with respect to theta of cosine of theta raised to the power of 3. Now here we can use the power rule. So that means we have 3 times cosine of theta raised to the power of 3 minus 1. Now since we have cosine theta instead of theta, all we can do is use the chain rule. We'll need to multiply it to derivative with respect to theta of cosine theta. So this is going to give us 3a multiplied to cosine squared theta. Now what's the derivative of the cosine function? So that's negative sine theta. So we have successfully obtained the value of derivative of x with respect to theta, which is negative 3a cosine squared theta multiplied to sine theta. We're going to label this as equation number 1. Our next task will be to obtain the value of derivative of y with respect to theta. So we'll take the same route here. We'll obtain the derivative by applying the power rule here. So we have 3 times sine theta raised to the power of 3 minus 1. So this will get multiplied to derivative with respect to theta of sine theta. Now this is going to give us 3a times sine squared theta multiplied to derivative of the sine function as cosine of theta. So that's equation number 2. Our next task will be to obtain derivative of y with respect to x. All we have to do is take derivative of y with respect to theta divided by derivative of x with respect to theta, which we have already obtained in 1 and 2. So that means we have 3 times a multiplied to sine squared theta times cosine theta, and we're going to divide it with negative 3a times cosine squared theta times sine theta. So we have 3a and 3a cancelling out from the numerator and the denominator. 1 sine theta from the denominator and 1 from the numerator goes away. 1 cosine theta from the numerator and 1 cosine from the denominator goes away, which leaves us with sine theta over negative cosine theta. So that means derivative of y with respect to x is given by negative, let me write it down. We have sine theta in the numerator and cosine theta in the denominator. This is simply equals to negative tangent theta. Now we have to obtain the value of derivative of y with respect to x at theta equals to pi over 4. So that means derivative of y with respect to x at the value theta equals to pi over 4. So this will be equals to negative tangent of theta. So in place of theta, we have pi over 4. We know that tangent of pi over 4, this value is equals to 1. So that means our final value will be negative 1.